What's up YouTube, this is Dennis Panuta for tutorials.eu. In this video you are going to finally understand what IEnumerable and IEnumerator are, their interfaces, but you are going to understand a little more about when to use them, how to use them, what the advantages of using them are, and how they are related to lists, then arrays and other types of collections. So you will understand collections a lot better after this video. It's definitely something you should have in your arsenal when you are a C# developer. So definitely check out the video until the end and fully understand it. And of course, leave comments with ideas if you have any, and hit that like button if you like the video. All right, let's get started. In this video, we're going to look at some very important interfaces that you should understand once you want to become a more advanced C# developer. And that is the IEnumerable interface as well as the IEnumerator interface. Okay, so you should understand interfaces before watching this video, because otherwise some of the concepts won't make sense to you potentially. So I really recommend to check out the interface video that we have to offer as well. Okay, so the IEnumerable interface is the base interface for many collections in C#, and its job is to provide a way to iterate through a collection. So this is why we can use foreach loops to go through a list or a dictionary, because they are inheriting from the enumerable interface, so the IEnumerable interface. In simple English, when a collection class implements the IEnumerable interface, it becomes countable and we can count each element in it individually. So there are two different versions of the IEnumerable interface. One is that works for generic collections, where you have this IEnumerable opening bracket T closing bracket, and then the IEnumerable interface for non-generic collections. So first of all, we need to understand what collections are. Like arrays, collections are classes that we can use to store many objects at the same time, or a collection of objects, hence the name collection. Unlike arrays, collections are not limited to one type of object. So instead, in a collection, we can store as many types of objects as we want. Also, collections are not fixed in size like arrays, for example, by their length. We can add elements to them as we go, and the collection will adjust its size. In this case, it's not called length, but count. And we're going to see how to use that. So why do we need collections? Well, let's imagine this scenario where we are building an attendance system for a school and we want to add students to our system dynamically over time. Once we define our student class and start creating objects of the type student, we will face an issue. How are we going to store them? Well, storing them in an array is a bad idea for a few reasons. First of all, arrays are fixed in size. So if we create an array of 500 students, then we can't have any more than that. Secondly, what if we decide to add other types of objects to our system, like teachers, employees, and so forth? Well, since an array is fixed in size and can only accept one type, we can use collections to solve the issues. So we use them to store, manage, and manipulate groups of objects more efficiently. So collections can be used to do a lot of operations in a group, for example, adding, deleting, replacing objects, searching for particular objects, and even copying objects. So now there are two different types of collections. Non-generic collections, which we can use to store any type of object, and they are inside of system.collections, inside of that namespace. And then we have the generic collections, which is limited to one type of object. So we use them if we are sure that we don't need different types of objects that we want to store. And they are located in system.collections.generic, so in that namespace. So non-generic collections, let's look at some examples. So here we have this int num equal 1 is 5. Then we have this float num2 is 3.15. String name is, for example, Dennis. And then let's create this new array list, my array list, and we add num1 to it. Then we can add num2 to it, and we can add a name to it. So you see here that they're non-generic, which means it allows us to use different types. So one type was an integer, the other type was a float, so num2 was a float, and the name was a string. So we can add all of those to our array list. They're of different type. So you see, we're using the add method in order to add them to our list. Now we could use the methods that we were talking about before, which was copy, delete, replace, and so forth. We could use them in here or with this array list, because an array list is a non-generic collection. And now we can go through all of the elements in my array list using the foreach method. And because it's not of one particular type, so the elements inside of our array list are not of one particular type, we need to use object element in my array list. We cannot use int because there are floats and strings in there as well. We cannot use float because there are ints and strings as well. So that's why we're using object, which is a very generally used type that allows all kinds of types. The object type is basically incorporating all other types. So now let's look at the generic collection. So this one will have animal 1, animal 2, animal 3, and it will be of type list, and we're going to call it my list. So you can see this list can only store strings. So we're creating this strings list. And since the list is a generic collection, it can really only hold one type of objects. So we have to specify that type when defining that list. So here we are specifying it's of type string. So the data that we can pass to it or save in it or store in it will only be strings. By giving the type between an angle brackets, in this case here you can see angle brackets string like this. So we technically would say that my list is a collection of type list string. In upcoming videos of this chapter, we will explore different types of generic and non-generic collections, and we will discuss the benefits of each one of them and how and when to use them. Okay, so this was just a very quick introduction to the two topics. We're going to see a bunch of examples and then it will become a lot more clear. Quick pause. In this video, you'll learn something about C#. And if you want to learn everything there is to know that you need for the fundamentals and to become a real C# developer, then definitely check out my C# masterclass, in which you're going to learn all of the things you need to know about C#. So you're going to learn how to do the basics, how to use object-oriented programming, how to use WPF in order to create your own user interfaces, how to use databases, how to use LINQ, how to create your own games using Unity, and a lot more. So if you want to become a real C# developer, definitely check out the link in the description below. Okay, so these two that we have here, let's look at those. Since the generic collections were introduced after the non-generic collections, it's recommended to use the generic collection. So they're basically an improved version, so to speak. So if you are creating a new project, it's recommended to use the generic version, because an IEnumerable for non-generic collections needs to apply or perform boxing and unboxing, which basically is the conversion of types of objects. And we will later explain how to use the IEnumerable interface, so the generic collections interface. Okay, we're not going to go over the non-generic collections interface because it's not recommended due to the boxing and unboxing, which just is less efficient. So now let's look at the difference between the IEnumerable and the IEnumerator. You maybe have heard those before. So the IEnumerable interface contains a single method that you must implement when implementing this interface. And we're going to do that later on in our particular example here, so it makes a little more sense. So the getEnumerator method is the one that you need to implement, and it returns an IEnumerator object. Okay, so this method that you need to implement when you want to use a IEnumerable for your class, or when you want to implement it for your class, you need to have this getEnumerator method, which then returns an IEnumerator. So the IEnumerator provides the ability to iterate through the collection by exposing a current property that points at the object we are currently at in the collection. Okay, this is a lot more complicated than it will be once we actually run this in our particular example. Okay, so we're going to build an example fully understanding what all of this means. So this is just to prepare you what you can expect. Okay, so let's get started. finally getting away from all of this theory, let's actually look into practice. So let's create this little class called dog, and I'm going to put it in the same file to keep things simple. So we have this class called dog with a name, and we have this boolean called isNaughtyDog. So we will basically check if the dog is naughty or not, and based on that we are going to give him treats. Okay, so if he's not a naughty dog, he will get less treats than if he's a good boy or a good dog. Okay, so the constructor here basically just sets those two values. So when we create a dog object, we are going to give it a name and a boolean whether the dog was naughty or not. And then we have this giveTreat method, and this will basically just print out that the dog said woof. So for every single treat that the dog is given, he will say woof. Okay, so basically if he's a good dog, he will get 2 treats and he will woof twice, and if he's a bad dog or a naughty dog, then he will only woof once because he will get less treats. Okay, so now we have this class dog, and we can now go ahead and create dog objects. So let's have this other class. Let's assume we have another class that will use dogs inside of a list. Okay, so we have this dog shelter class. So this dog shelter class will have a list of dogs. So therefore we need to make sure that we have this using system collections generic, because list is a generic collection. Okay, so here at the top you will see that now you have this using system collections generic. Okay, so now that we have this dog shelter and we have this list of dogs, in the constructor of this dog shelter, the only thing that we're going to do is to initialize this dogs list with a bunch of dogs. So we have the Casper dog, or a dog called Casper. He's not a naughty dog, but Sif is a naughty dog, Oreo is not naughty, and Pixel is also not naughty. So don't ask me how we come up with these names, but that's basically how we're going to call those dogs. You could, of course, make this whole application a lot more complex, but our idea is really just to use this list of dogs to iterate through the dog shelter, to go through the dog shelter basically, and based on whether a dog is good or not, or a naughty dog or not, we're going to give him 1 treat or 2 treats. So now let's go over to our main method, because that's where our starting point of our application is. And at this point, let's go ahead and create a dog shelter here. All right, so we have this dog shelter called shelter, and it will be a new dog shelter. So we initialize it straight away as well, so that we can use this shelter object, because the shelter object will contain a list of dogs, right? So now what we want to do is we want to iterate through the list and check if we want to give them treats or not. So let's create a for each here, like so, double tap in order to prepare it for us. So what is it that we are going to go through? Well, we are going through a dog, and we're going to call it dog. So every single item inside of the list will be a dog. And then the collection that we want to go through is in fact going to be the shelter, like so. Now we have a little problem. Once we hover over it, we see here name of collection or array to iterate through is the shelter, but the for each statement cannot operate on variables of the type dog shelter, because dog shelter does not contain a public instance or extension definition for getEnumerator. Okay, so there we have this getEnumerator. So what does that mean? Well, this means that we need to implement the interface IEnumerable right here for our dog shelter, because this dog shelter has a list that we want to iterate through, right? Because if you look at it, shelter, well, our dog shelter, that's the shelter that we want to iterate through. And in order to make it iterable, we need to implement the IEnumerable here. And what type of objects do we want to enumerate? Well, in our case, it's going to be the dogs. So we want to be able to go through the dogs inside of the dog shelter, because, well, we have this list dogs and it's initialized here in the dog shelter constructor. And we want to make sure that we can just go through all of them and do something with the dogs, like pet them, or in our case, give them a treat. So once you implement this and you go up here, the error disappears. So suddenly it's fine because, well, our shelter, which is a dog shelter, now follows the instructions that were just given to us that it needs to implement the IEnumerable here. So this is the generic IEnumerable because we have this dog right here, right? Because it's not this one. It's the one with the type that we're giving to it. But now once we hover over it, we get another error. It says dog shelter does not implement interface member IEnumerable dog get enumerator and the IEnumerable get enumerator. So we can manually put them in there, but the beauty about using an IDE is that the IDE can do a lot of work for us. So you can click on show potential fixes and then click on implement all members explicitly. And it will then add the collections namespace for us, and it will take care of adding those two methods for us, or those two members. So once we click on this, you see that this error will disappear. And if we scroll further down, you will find that now we are returning an IEnumerator of type dog and a non-generic IEnumerator collection. So now we haven't implemented it. That's why we have this throw new not implemented exception here. So we need to change that. Here we can now implement what should happen with our getEnumerator method once it is called. So in order to fix it, what we're going to say here is just return dogs, our list dogs dot get enumerator, just like so. And that will be the implementation, because our dog shelter is now implementing the IEnumerable interface, and our list here is in fact if you hover over it, a list is a generic list. Okay, and now we can take these list dogs and we can get the enumerator for every single iteration that our for each loop will go through. So basically it will return the individual dogs, and now what we can do is we can actually use the dog in our for each loop here. So that basically means that we can now go ahead and check if the dog is not naughty. So not dog dot is naughty. If that's the case, that basically means if the dog is not naughty, we are going to call the method give treat, and we're going to give him 2 treats. And otherwise, if he was naughty, because we can't not give treats, we just love dogs too much, we are just going to give them 1 treat. Okay, like so. And at this point, we can run our application. And we will see Casper said woof 2 times because he's a good dog. Sif is a naughty dog, so he gets only 1 treat, and he says woof once. Oreo does it twice, and Pixel says woof twice as well. All right, and that is basically how you can make your class follow the instructions or implement an IEnumerable so that you can loop through a list using the for each loop, for example, as we have it here. Okay, now you might wonder, why are we not implementing the getEnumerator with the IEnumerable, the one that is non-generic? Well, that's because we don't use a non-generic example, and our dog shelter is not non-generic either. But it's just that you need to implement it when using the IEnumerable interface, because otherwise, if you get rid of it, we will get a warning here again. You see here, or actually an arrow. So we need to make sure that we have this method in there as well. All right, so that's it for this video. In the next video, we are going to look at another example where we are going to take advantage of the IEnumerable even more. Okay, so this was just a little bit of an introduction. I know this topic is rather complex and complicated, but we're going to take advantage of them a little more. And now, by the way, just a quick one, just a summary here. When is it recommended to use the IEnumerable interface? Well, you should use it when your collection represents a massive database table. So you don't want to copy the entire thing into memory and cause performance issues in your application. because the database could be huge, right? It could have millions upon millions of entries, and you don't want to have to load the whole thing to iterate through it, but you just want to load as much as you require for the current process, whatever you want to execute. And then when should you not use the IEnumerable interface? Well, when you need the results right away and you are possibly mutating, editing the objects later on. In this case, it is better to use an array or a list. So when you want to be able to mutate or edit objects later on, and you don't need the results straight away, use an array or a list. Otherwise, use an IEnumerable because it's going to be more efficient. In the last video, we looked at how the IEnumerable works from a technical point of view. In this video, we are going to check out how we can take advantage of it. Because the cool thing of IEnumerable is that the list types that we use usually, such as list, queue, array, all of those are in fact implementing the IEnumerable interface. So this gives us a lot of freedom, and we're going to see what we can do with it. So I'm going to have this method called getCollection, and what it will do is it will return an IEnumerable of type integer. Okay, so we will need to return something at one point, so let's return null for now to get rid of this error here. And now if we want to use the IEnumerable, we can see that we need to add system collections generic, because here we're using integer. We're going to return an IEnumerable integer, so that means we need to make sure that we have this namespace collections generic. All right, so now what shall this getCollection do? So basically we can have multiple options. So if we select the option 1, our getCollection will return a list. If we take the option 2, it will return a queue. And if we take any other option, such as 3, 4, 5, whatever, it will return an array of integers. So this getCollection method will return some entirely different types of lists depending on the option that we're going to pass to it. So that's the idea behind this getCollection, and that's also the power of using the IEnumerable interface, because as I said, list, queue, and array are all implementing the IEnumerable interface. Okay, so let's look at it. Let's create this list, which I'm going to call numbers list. And I'm going to initialize it straight away. So it will be a list of integers, and the numbers will be 1, 2, 3, 4, 5. And then we're going to create a queue with a bunch of values. So here 6, 7, 8, 9, 10, and we're going to enqueue them to this numbers queue. So you see queue, numbers queue. Now, if you hover over it, you can see it's also a generic collection. Okay, the same goes for the list. It's a generic collection. Same goes for the IEnumerable generic collection. So you can see there is a certain connection already. So now what I'm going to do is I'm going to check what are the options that are taken. So what is passed to my getCollection method. If it is 1, then I'm going to return my numbers list. If it's going to be 2, I'm going to return my numbers queue. So an entirely different type of list. Okay, so it's containing different type of information and different values, but it's really just an entirely different thingy. Okay, so it's not a list, it's a queue. And a queue is not a type of a list. So queue is not inheriting from list or something like that. Okay, so that's really the interesting thing here, what we can do. And otherwise, so if the option is anything else, we're going to have this else case where we are just going to return 11, 12, 13, 14, 15. Now in this case, you can see this return statement here is never going to be reached. So we can get rid of this line here entirely, because it's basically never going to be reached if we have this if else statement with a bunch of returns here. All right, so now that we have this getCollection method, let's actually use it in our main method. So here in the starting point of our application, let's create an unknown collection. So just an IEnumerable collection that is going to be a generic collection that uses integers or holds integers. And we will use this variable to store the collection that will get returned by the getCollection method. So by this method that we just created. Now, let's actually just assign getCollection1 to it. So because we passed 1 to it, unknown collection will now hold, let's look here, the list here, this list here, not the queue, but the list. Okay, so that's a really cool thing. So now we can display this on our console saying for each number in the collection we got back from the getCollection. So we're going to use the for each in order to get all the numbers that are in our unknown collection. Because if something is an IEnumerable, so if a list type, like a list, like an array, like a queue, is of type or is implementing the IEnumerable interface, then we can iterate through it using a for each loop, which is what we're doing here. So we're going to go through this unknown collection, and for each number, we're just going to write it onto the console. Okay, so let's run this real quick. And we can see 1, 2, 3, 4, 5 was printed out. So that seemed to have worked. Now let's do the same thing, but with collection 2. So get collection, and we pass the option of 2, which will now return the queue. But it will store it in the base type of our generic collections. Okay, so unknown collection is the base type IEnumerable, which is basically the base type of our list and our queue. So now we can just assign it to it, because unknown collection doesn't care if it's a list, if it's a queue, if it's an array, because all of them are following the instructions of an IEnumerable. So they follow the implementation of it. So now if we run this code now, it will display the queue here, 6, 7, 8, 9, 10. So this was a queue int, and it displays it for us. All right, and now let's look at this if we enter any other type of option. So let's say we give it the option 5, which will be returning this else case here, which basically will return an array of numbers. Okay, so let's run this again. And we will see that now it returns 11, 12, 13, 14, 15. So of course, these were the ones from before. So these for each loops, okay, we didn't delete them. Of course, we could get rid of them to see that now it only will do the array or display the array. So there we are, it only displays the array. That's it for this example. You see that we have quite an advantage of using IEnumerable, so the base type, so to speak, of any type of generic list that we want to make iterable, like the for each loop, well, for each loopable, so to speak. And that's really the power of it. Really useful stuff. In the next video, we're going to look at another example where we're going to pass an IEnumerable collection as a parameter for a method. Quick pause. In this video, you'll learn something about C#. And if you want to learn everything there is to know that you need for the fundamentals and to become a real C# developer, then definitely check out my C# masterclass, in which you're going to learn all of the things you need to know about C#. So you're going to learn how to do the basics, how to use object-oriented programming, how to use WPF in order to create your own user interfaces, how to use databases, how to use LINQ, how to create your own games using Unity, and a lot more. So if you want to become a real C# developer, definitely check out the link in the description below. Welcome back. In this video, we're going to look at IEnumerable one more time, and it's another demo where we're going to see how we can pass an IEnumerable to a method as a parameter, and this gives us a lot of flexibility because, well, similar to what we have when it comes to inheritance in object-oriented programming, where the instance of a child class can be passed the same way the parent would be passed into a method call, for example, as the parameter. Something similar happens when we are working with collections that implement the IEnumerable interface, as we have seen in the last video, where we could replace the IEnumerable, so to speak, with lists, with queues, as well as with arrays. Okay, so let's go ahead and just create a new method here. which will in fact take an IEnumerable collection as the parameter. Okay, so I'm going to put that down here. And as you can see, we're using the IEnumerable, which is of course going to require the generic collections namespace up here. All right, now we can use it throughout our file here. And what I'm going to have is basically a sum that will store the sum of the numbers in any type of collection. So in our any collection. And then we're going to go through each item in the collection and add that together and put it into sum. So basically summing up all of the values that are inside of that collection. And then we are just going to write out the result of the console. So console write sum is, and then the sum. Okay, so that's the idea behind this collection sum. Now the cool thing is we can pass any type of collection to it that implements the IEnumerable interface. This means that we can pass a list, we can pass an array. So we have a bunch of options here. Okay, so let's actually make use of that. Therefore, I'm going to set up a list like so in my main method. Okay, list number list. So this will just be a list of numbers. Then I'm going to do the same thing with the array. So I'm going to create a number array of integers. Then I have a new line. Well, I'm creating a new line using this write line statement. And I'm going to call my method collection sum, where I'm going to pass the numbers list, which is this list full of numbers 8, 6, and 2. Okay, so if we pass that and then run the program, it will display the result of 8 plus 6 plus 2, which is going to be 16. All right. And now the cool thing is we can, of course, do the same thing with our numbers array, like so. So here we are passing the number array, which is an entirely different type, right? So this is not a list, this is an array, and we're just passing it in. And if we run it, we will see that it will work the same way. So it's going to say sum is 12. And that is the sum of 1 plus 7 plus 1 plus 3. So that's really the advantage of using the generic type IEnumerable here. So basically the base type, you could see it's not really the base type of a list, right? But the list class implements the IEnumerable. So if you go over to list here, you see it follows the instructions of the IEnumerable, both the generic as well as the non-generic options here, as you can see. And that's really the cool thing here. That's really the power of using IEnumerables. So yeah, that's it for this video. Now I hope you have a certain idea of what you can do now with the IEnumerables. And whenever you come across the IEnumerable collection type, you will not be confused because they are used quite a bit in programming. All right, so now you should be a pro in collections and fully understand what IEnumerable and IEnumerator does for you and how you can use it, because those were topics that I had struggled with when I began programming as well, and I thought it would be a good idea to share the knowledge about it with you to, well, make your life a lot easier when it comes to working with collections in the future. So I hope you enjoyed it, and well, if you did, then please leave a like. And also, if you loved the video and you want to learn a lot more about C#, definitely check out the C# masterclass. You can find the link in the description below. And if you haven't subscribed already, please do so now, because it really helps us out and it will help you out in the long term as well, because you are going to get notified or at least recommended a bunch of our videos in the future, which we are working on constantly to create the best possible C# as well as Unity content. Okay, so for now, check out one of those two videos and have a nice day.